Hi everyone, and welcome to another episode of the Research Spotlight. This is the show where we get to meet and listen to researchers who are doing amazing things in their field. And a very warm welcome to our podcast listeners. My name is Tisha, and today I have the pleasure of speaking to a very hardworking young man. He is a postdoc research associate at the University of Minnesota, USA, and he is specialized in translational MRI, using MRI to evaluate different cancers in the body. He's going to tell us more about that. But prior to that, he graduated with a PhD in MRI physics from the University of Houston, USA, a postgraduate diploma in condensed matter physics from the International Center for Theoretical Physics, ICTP, Italy, and a Bachelor of Science degree in physics from the University of Eldoret, in Kenya. My guest for today is Dr. Erick Buko. Hi, Dr. Buko.
Hey, Tisha. How are you doing?
I'm very well, thank you. And thank you so much for joining me here.
And thank you also so much for giving me this honor to be here.
Yeah. So we've got to know a bit of your bio. From your first degree to ICTP and then to the US. So can you give us a little bit more of your background? Where you grew up and then all that.
Yes, sure. So this guy was born in a city called Migori in Kenya. That is where I was raised up, and I went to school, primary school over there. And so it is through that school when I was still young at primary school. That is when I had this desire of doing research at a medical institution, but I did not know how to go there. So that is you just have this desire, but you don't know how to do it. So I made my plan at primary school that okay, if I go to high school, then I should be able to do sciences. And then geography was also part of it, and of course, then I ended up also doing another business studies. Then from there, I applied to it is called the biomedicine. But unfortunately, for whatever reason, I was just called in a Bachelor of Science, BSc. So I found myself in a BSc, and I tried I need to move to maybe biochemistry, analytical chemistry, but all those ones failed. So after reaching the university, I just say, okay, you know what? Once these things have failed, then I have now to do a Bachelor of Science. I need to do chemistry, I need to do mathematics, and I also need to do physics. So I wanted to do all those subjects because I thought, okay, maybe this ones will take me towards the direction, the goal which I wanted. But when we reached the second year, so the thing was that you can't do all the three.
So, yeah, you have to choose.
You have to choose. So I had the option of, okay, if I'm going for chemistry, then it is just going to be chemistry. But if I do maths, then I'm going to have physics. Or if I do physics, I'm going to have mathematics. Then I said, okay, the best option will be maths and physics, So that is how I ended up doing my maths and physics. And as I continue with the math and physics, I become more interested in physics.
Physics, yeah.
And then I joined the group of material science. So in the material science, most of the calculation is just about, the waves and all this kind of stuff. So we did a lot of semiconductor work.
With physics.
Yeah, just in physics. So you do like the semiconductor material, you look at the band structure, all those kind of beautiful stuff in physics, And then after graduating with a bachelor degree, I was called back in a mentorship program by my professor called Professor George Amolo, Dr. Nick Macau. Professor George Amolo is currently at the Technical University of Kenya. So in that program, again, we did a lot of, calculation in physics, electronics, and all this kind of stuff. Then I got the opportunity at ICTP. So at the ICTP, I got a condensed matter. So it is more like, a branch of material science.
Yeah.
So over there, I went with this notation that, okay, I'm just going to do electronic structure because that is what I know. Yeah. But when I went there again, I was introduced to water, the properties of water molecules, molecular dynamics. And then because I wanted to do something, related to the material science, I was like, okay, I can work on water molecules, but I want it in terms of electronic structure and all this kind of stuff, just to tie it back there. But again, at the ICTP, when we were there, then there was this arise of cancer cases, or at least I became aware of about the increased number of cancer patients in Kenya. And then they used to go, they have to go to either India, they go to United States for those kind of treatment. So I was thinking that, okay, how can I be useful in this kind of area? Then again, the ICTP introduced this course called medical physics. So again, I became like, okay, then there is a way the physicists can do this kind of stuff, right? So I did apply there for sure, but unfortunately I was not selected. So that is how I started now thinking about the medical physics, because I had no idea about it. But when ICTP introduced it, then I became aware of it and started trying to figure out how can I be of good use in this. So from there again, the opportunity came to come to the United States. Then I went to the University of Houston. By then, the University of Houston was not officially offering the medical physics per se, but fortunate enough, there were groups who are offering what is called the imaging physics. So one group were doing like something like that, X-ray, and then another one was doing MRI, So I look at these two groups while also thinking about what I can do in Kenya. That is the main thing. And then I realized that the people who were doing X-ray were more like, they're dealing with light and all those kind of properties. And then the person who was doing MRI was actually somebody who graduated with the condensed matter. So I'm like, okay, I'm home. Yeah. And then I also read about the MRI. Then I see like, okay, the MRI also uses the water properties, the magnetic properties of water to identify this tumor and all that stuff. So again, I said, okay, I have a knowledge of water from my ICTP. This guy is also a condensed matter guy. So I'm home. Let me just deal with this, So that is how I shifted. Yes, I just shifted from condensed matter directly to MRI physics. So inside there, because being a physicist, again, what I just decided to do was to do something related to physics. So I did diffusion. So I basically look into, how water molecules diffuse within the tissue and what kind of information it can tell us, And while working on that again and attending the conferences and all these other activities, you see what people are doing. And then you're like, wow, there is a lot more interesting information which we can get over here,
Yeah.
So with that, you start now looking at, not only should I look into physics, but I need to look other areas too. And then like, okay, apart from this one, I can also do 1, 2, 3. So you just work that way, you get a lot of more information around MRI, and then we reach a point where now you're about to graduate. Now the question is, what next? Yeah. And then again, you look at yourself like, okay, the reason why I'm doing this one is tied to what I want to accomplish back home, right? Then here, I'm doing very nice stuff of physics. Yes, it is cool for the physicists, but how is it going to help the community? That is another question. So then I came across another group called, or another area in MRI called the translational MRI. So what they do in the translational MRI is that this cool stuff we have in physics, how can we apply them in the patient? How can we now translate it? So that is why that translation term is.
Translational MRI.
Yes.
Okay, so you have been talking about, or you've been mentioning MRI, which I know is magnetic resonance imaging, right?
Right.
So, in a layman's language, what is this research work that you are doing? What problem is it solving in the society?
Yes, that's a very good question. So this is so Tisha, when you have a cancer, and then
when someone has
no. okay. Let me use someone else, right? I cannot use a dog because dogs also develop cancer.
They will continue.
Okay, so if we have a patient with a cancer, they're always being directed to the MRI. And while in the MRI, we need to be able to identify the location of that tumor or the cancer, right? So what they usually do is that they induced a chemical inside your body. It is usually called the contrast. So that one is just to enhance the visibility of the tumor. So we are able to locate it exactly where it is. That's the main purpose of that. But the problem with this contrast agent is that if you use them for a long time in patients, then they're going to deposit in their brain.
In the brain?
Yes, in the brain. And now the long-term effect we don't know, So right now we know that, okay, we are able to see it, but we don't know the long-term effect. Another thing with the problem with this contrast agent is that they are made from heavy ions. So that means that if you have a kidney problem, then your body is not able to flush them out fully. So you can develop some complications. So that means if you have kidney problem, then they cannot use this method to identify the tumor in your body.
Yeah.
Another challenge with this contrast is that when you put it, there are some people who have what is called the contraindication. So their body react with these chemicals. So in such case, it can bring a lot of problem, right? So you don't want to expose people to that kind of stuff. So my work, which was my PhD work, was to find a way in which we can get the same information without using this contrast agent. Yes. So that means we will be very able to, actually apply for everyone. We don't worry about the position in someone's brain. We don't worry about somebody with a kidney problem, or we don't worry about, somebody with who will react with this, with that kind of chemical. Wow. So that is the problem we are still solving part of it.
Solving, okay. So far have you gone with that?
Yes. So far the result is very promising.
Promising.
And we have started utilizing it in different places. But of course, you have to make sure that it is properly working before it is being released over there, right? So wow. that is one thing, or one of the things we are doing. Another thing we are doing, what is called the quantitative MRI. So the quantitative MRI simply means that we assign a value, to a particular thing. For example, I can say that, okay, let us look at your liver. Oh, let me not use you. let me say you. Yes. So liver, brain, or whatever it is, right? And then we want to quantify, we want to assign a value to maybe the amount of the fluid that flow within that particular region. Well, let's say, let me use a brain for a simple purpose. So you want to know how much fluid is really flowing within a given region of the brain. So if I know that one for the normal brain, so anything that deviates from that normal it will indicate that there is a problem, right?
Mm-hmm.
So that means that we will be able to actually identify tumors at a very, very early stage.
Yeah.
That is another aspect of it, Yeah. So those are some of the things we are solving, among many other things.
Other things. Great. Interesting. Thank you for sharing with us. So, what has been some of the challenges that you have faced in this line of career path that you have chosen?
Yes, there are several challenges. I can talk about the general, for example, for the PhD in general, is that the main work which you do is sit down, and think. That's the main thing you do, So sometimes you want to go out, or people are going out, but you have to remain inside on your seat, and just look at your data and just thinking and continue thinking, So that is one challenge, forgetting about the social life, and again, of course, you how do you say, the contact or the relation between you, the family, and the friends, you kind of decrease them, So it is more like you're being isolated.
Yeah. Like a sacrificial kind of work, right?
Right. Yeah. So that is true. Another challenge will be the fact that when you do mathematics, it is very interesting in a piece of paper. You do it very well. You do your simulation. You say, oh, wow, this is good. But then you go to do the actual experiment. You realize that, oh, things are not the way I wanted them to be, So again, that one is.
So, are you? Are you modeling, or are you going to the laboratory to perform experiments? Is it theoretical?
Yeah, very good question. So in our work, we do all this. You sit down, do the analytical work, then you do a modeling study. So you have to, of course, that analytical work is what we're calling modeling, but then you do a simulation, right, to test your algorithm or whatever you have developed. And then from there, you move to a non-living thing. You go and do experiment with the non-living things. Then after that one, you do now with the living things, volunteer, and patient. So it is all round. You start from scratch, nothing, from mathematics, and then you translate it all the way to the human being.
Wow. Yeah. Interesting. So I'm going to ask you about how usually your day is like when you wake up in the morning. What are some of the things you do in the day? What you do in general? But we have a food security channel saying that interesting host, Tisha. Thank you. So food security channel is an great channel. There's lots of useful information about how to yield, how to increase crop yield, etc. So check that out if you are interested in agri stuff. So Dr. Buko, back to you.
Yes.
How is a typical day like for you as a researcher?
Yes, so it depends on the day, actually. You cannot really say that every day it is like this. Yeah. But most of the day, the best thing you do is sit down and think. That is the main thing you do. So
wow.
That's what I can say, the most thing you do. But sometimes, for example, I need to do mathematics. Obviously, I'm going to do calculation, and then I'm going to get the data, then make analytical, and then reason with the data, Because most of the time, when you are being asked a question, maybe with your committee or a group of scientists, you're not going to say that, okay, this is what is happening. No, you have to have the data. And then from the data there, you have to walk them through. You just say, okay, this is what is happening. So you have to think. They can ask you that, okay, you have this graph. So why is it that? Why is it different? For example, I measure the brain. Mm-hmm. It come out very nice. But then you go to the liver, it is completely a different story, So you have to know what is the difference between the chemical composition in the brain and that one of the liver, you know. So you will be able to, you have to have a reason. So most of the time you just think. And of course there is a lot of meetings here and there. You also if you have a problem, of course you have to, consult here and there. Yeah.
Wow. So we have George Amolo saying, nice to hear from my former student, fired up and inspiring. George Amolo from Nairobi, Kenya.
Yes, that's my professor.
Hello, Prof. Yeah, thank you for teaching him. Now he has gone far. He's a great guy now, and we are so proud of him and proud of you also as a teacher and a professor. So,
Thank
Dr.
Yes.
Yeah, we know that publishing of articles is one of the important stuff for your researchers. Okay, so can you tell us a bit more about that? What goes into that? If you have been able to publish, or if you are in the process of publishing a paper or an article?
Yes, Tisha, that's a very good question. And in fact, yes, there is a lot of things that goes into publication, depending on what do you want to tell, what story do you want to tell. There is what is called the literature review. So you just want to say, okay, these people have done this one, people have done this one, but you want to bring all of this together and then give people a summary, because that is also an input. Rather than going all across 17 or maybe 100,000 papers, then you just get one and then you are able to go, right? So that is one article. Then there is another one, they are calling it, there is a full paper. So the full paper is what you bring, which is very new to the field, right? That means you have to think through, okay, what are you going to contribute? What is the new idea you're bringing? That is per se. And then there is another one which is called a letter. A letter is you tell people, hey, this one we can do it this way, So it's just a short thing. So depending on what do you want to tell people, so that is very much important. And of course, it takes a lot of effort. You have to write it. You have to rewrite it again and do rewriting. Until those people get satisfied that, okay, well, this is what publishing, right? So that is the much effort. But I think, to me personally, what I value most is not how many papers I do publish, but how many citations I do have, because that indicates the impact of my work.
Yeah.
Yeah. So if I have 20 papers and no citation, then I'll be like, then it's only me who knows this thing, right?
Yeah.
But if you have something and there is a citation on it, then you're like, okay, at least you are making some impact. Yeah. Wow. So that's what I value most. Yeah.
Wow, interesting. So you have already mentioned that, I mean, on a day, usually you have to do a lot of thinking, right?
Right. Yes.
So apart from thinking too much, apart from always thinking, what are some of the other qualities that a young researcher should possess? There may be some younger people watching you who aspire to be like you one day. So apart from the ability to be able to think, what other qualities should that person possess?
Yeah, so one of the things you have to know that once you enter a field, it is not just you. There is a group of people. So you should be able to work by yourself, but at the same time, you should be able to collaborate with other people. And also keep your eye open. Maybe somebody may be having something which is completely different from yours, but maybe there is a slight idea in which you can help. In such case, you just go and say, I can see this one here, let me just help. So that one you can just help, maybe within one day or so you are done. So you have to be somebody who is able to work by himself, or at the same time you will be able to collaborate with others. Again, another quality is that accept if you don't know. Most people, they're like, oh, no, I have to know. No, if you don't know something, just say, I don't know. It is also correct and fine, and people will understand. If I don't know something, I don't know.
I don't know.
Yeah, that is another thing, I think, the quality that most people don't want to, If you ask something, then you just feel like, okay, I should be able to give an answer. But if you don't know, I just advise people, just say, I don't know.
Yeah.
Right.
Wow. Interesting. So we have just seen Professor George Amolo, who was your teacher, and I'm sure you have met, you have passed through the hands of other great professors.
Yes.
But do you have a mentor that you go to? With all these things you are doing, I know sometimes it gets a bit difficult. It gets a bit tough, and then you would need someone to maybe go to draw some inspiration from. Do you have someone like that?
Yeah, so Tisha, when you are in school, definitely you should have a mentor. That's for sure. There is no doubt about that. So whether a bachelor degree, Professor George Amola was there, Dr. Nick Makau was there, ICTP, we also have so many professors over there you could just run to for guidance and all this kind of stuff. At the University of Houston, yes, I had my advisors. They were always willing to help. If you have a problem, you can go talk to them, because the life of research, like when you're a student, sometimes you feel like, oh man, I need to leave this place. You feel like giving up. So you need some energy,
Yeah.
You need someone to tell you that, okay, this is difficult, but you can do it. You can do it. So you need those kind of people, and also your colleagues, the students that surrounds you. Those are very important because they are also facing the same challenges. So you sit down together and then discuss, and then you see, okay, how can we do it? If somebody is about to give up, then you go and talk to the person. You tell him that, okay, what can we do to assist you? Something like that. So whatever you can do, you do it to help others as well. And then you work as a team. That is why being a teamwork is very, very important.
Yeah. So yes. Are you also available to mentor others, or do you already have mentees?
Yeah. So that's a good question, Tisha. And I think I believe on this like a staircase kind of walk, where there is somebody up holding my hand, and also there is somebody below, I'm holding their hand. Through that one you learn, whether through your mentee or mentor, whatever, you learn something. You cannot by any means know everything. So for the continuity, there should be people above, then you, and then there should be some people below. So you always walk in a chain, just like those small ants, the way they usually walk around. So yeah, I believe in that. So that's true.
Yeah. So from the beginning, you mentioned that it was the need for the need to solve the cancer problem in Kenya that influenced this career path, right?
Yes.
So yes. I want to ask, in general, how do you see the future of research work in Africa? Africa in general, not just Kenya.
Yes, I agree. Yeah, that is a very nice question. So we have this organization, which I'm a part of, is called the ISMRM, which is the International Society for Magnetic Resonance in Medicine. So, and they have a program called the African Spotlight, which definitely I'm an African, so I follow it more closely. And we see, some places like Nigeria, I see Egypt, South Africa, so there was a time they were giving presentation of what they do, the challenges they have, and all this kind of stuff. So we're just following it. And I know Kenya, like where Professor G. Amolo is, they are also starting the medical physics course, So it's showing you that the African is really coming up. And we are very sure that we can reach the same level at the international level. The only thing which I know is a challenge is money. So our government should be willing to spend money in research, And that's the thing, if that one happens, and we have young people, we have talented people, we have very smart guys, And if we can give them that opportunity, I'm very sure that we shall be able to drive Africa to where it's supposed to be.
Wow.
Yeah, so I really believe in the positive side. I just believe that it is gonna be good.
We are not there yet, but we will definitely get there.
We
right?
will be there. We will be there. I believe that.
Amen. Okay, so now PhD done, now doing postdoc. Do you have any plans of going back to Kenya to help with their ongoing research work there? Anytime.
Tisha, the main reason why I decided to do MRI physics and also involving in cancer, and actually right now I'm even exploring different diseases, because MRI is not really limited to cancers only, but we can also do other diseases. Like right now I'm working on, the back pain. Why do we have back pain? So those
I need that because I have back pain. So please hurry up.
Yeah, so we are also working on that, so there's a lot of things going on in the MRI which are so nice, but so like I was saying, the main reason why I did that was to be able to contribute something to the country, Kenya, and of course by extension Africa, right? So definitely I will definitely go and do it,
but not now, right?
No, I can't say right now, because right now I think I need to gather more tools. So when you go there, you don't, I don't want to go there and then just starting doing physics and stuff, but yet I'm not solving the community problem. So right now when I'm doing like, you do physics stuff, very cool one, and then you use whatever you have here, apply it in a clinical, for the clinical use. So I think the society will need the clinical use more than this beautiful stuff of physics.
Yeah.
Right. Yeah.
Wow. Dr. Buko, I'm so glad that you came, and I'm so happy. You're so glad and happy. Yeah, that you have shared your beautiful story with us. We celebrate you today, and we are so proud of your achievement. Keep it up. More grace to your elbow. Yeah. So, what will be your final words to our viewers?
Yes, my final words, first of all, to you first. Thank you for organizing this, and through this one, the Africa in general will be able to to get to know where the state of art is, and also they can get motivated to join the study, to join the research, so that we can really, carry the name of Africa to where it's supposed to be. And to the viewers and those who are planning to do the research, I can say that the most important thing is that when you decide to come and join the research, be aware that you are going to lose some friends for a short period of time. And then you should be willing to sit down and think. That's all.
Yeah.
Yeah.
You're willing to sit down and think.
Yes.
Yeah. Thank you so much for joining me here. It's been fun listening to your story.
Thank you.
Yeah, and thank you so much, viewers, for staying tuned to the end of today's episode. See you in our next episode. Bye-bye.